Yes, so we are looking at the solutions to our monthly test 2. And in the first one, they say that John invested $3,000 at 10% for 8 months. How much interest did he earn if he invested in a savings plan that paid simple interest? And also, B, if he invested in a credit union that paid compound interest. So let's deal with A. And in A, they said he invested in a savings plan that pays simple interest. So how much interest did he earn? Now the simple interest formula is simple interest is a principal by the rate by the time all over 100. So we have to put in our principal, which is $3,000. We have to put in our rate, which is 10%. We have to put in our time, which is 8 months, but remember that 8 months is really required to be expressed in years. So it'll really be 8 over 12 years. And then you have to divide that answer by 100. Now this 8 over 12 is where most of the issue came in. Many people forgot that. 99% of people forgot to divide by 12 because the time here must be in years always. All right, so it's very important that you remember to do that. So I'm gonna put this on my calculator, right? You can use your fractions to calculate the 8 over 12 part, right? And then you take it from there. So the answer, when you calculate this thoroughly, of course, would work out to be $200. Right, so that would be number 1A. What about part B? Part B requires us to find compound interest. Now the compound interest formula we have is A is equal to P into 1 plus R over 100 all to the power of N or T. Let's use T. So P here refers to the principal, A is the amount accruing, R is the rate of interest, compound interest, and T is the time in years. So let's put those things in. In order to get the amount accruing, we'll have to put in the principal as 3,000. That is what we are investing. The rate is going to be 10%, so you're going to put 10 over 100 here. And the time frame again is 8 over 12 years. So here again is where we had issues, people, not remembering to put that in place. So what happens there is that you work out the 1 plus 10 over 100. 10 over 100 is 0.1, so 1 plus 0.1 will give us 1.1. And the 8 over 12 could be reduced to 2 over 3. So on working this out, we will get a figure of $3,196.81 if we round it off to 2 decimal places. Always indicate what you are approximating it to. All right, so your interest, which is very important because this question asks you to work out the compound interest. And what the compound interest formula gives us is A, which is the amount accruing. Now remember, amount accruing is principal plus interest. So interest will be equal to amount accruing A, take away the principal. Very important. A lot of people would forget to do this calculation here in order to satisfy what they wanted here. So always read your question carefully and answer carefully. This is our philosophy. Always checking and rechecking as we go through. So the amount accruing minus the principal is going to be 3196.81 take away 3,000. And that is going to give us the compound interest that we were interested in, which is going to work out to be, let's erase this. This is going to work out to be 196.81. So $196.81 would be the answer for this one. Alright, so we have our two answers for number 1, and we will move on to number 2 next. We are now looking at question number 2, where we are told that Bob sold 4 bikes for $100 each at a profit of 20%. How much did he pay for each bike? This is a very tricky question because we are given the selling price, which is the final price, and we are asked to find how much he paid for each bike, which would have been his cost price, which is the initial price. Now, anytime we have to find what I call, or what we call, an initial quantity, there is a special formula that we need to use. And that formula, I'm going to write it now. It's F for final price is equal to I for initial price times open brackets 100 plus or minus X percent, where X represents the percentage change that I goes through. Now, in this particular application, F would be selling price, that would be the final price. The initial price would be the cost price. He's making a profit, so it will be plus whatever that profit percent is. If it was a loss, it would be minus X percent, but here it's a profit. So the equation would look like this. Let's fill in some information now. So we're putting in the selling price, which would be $400, because 4 bikes at $100 would give you a total selling price of $400. The total cost price would be unknown, and the value of X would be 20%. So we put the X as 20%. Right? In other words, the cost price is being increased by 20% to give us the selling price. So we have a calculation whereby the cost price, 100 plus 20 will be 120%, and 120% is really 120 over 100. Now, this means that 400 is equal to the cost price times 1.2. So in order to get our cost price, we are going to divide on both sides by 1.2. So this is what we end up with when we divide this line by 1.2 on either side. So our cost price, when we calculate 400 divided by 1.2, works out to be a figure of $333 and a third cents, or 0.333 recurring. Right? But if we use either this, or more accurately, if we use this, right, and we divide that by 4, we can get the cost price for each bike, which is what they're asking for. How much did he pay for each bike? This is what they're asking for. So read carefully, answer carefully. So in order to get the cost for each bike, all we simply do is divide the cost for all the bikes, which would be 333. Let's write that a little neater. 333 and a third, right? Divide that by 4, and we get the cost for each one of those bikes, the cost price for each bike, and that works out to be $83.33. Right, if we round it off to the nearest cent. Right, to the nearest cent. Right, which is equivalent to 2 decimal places. And so this would be the answer that they were looking for. In number 3, we have to expand and simplify the following. So we are looking at A, where there are 2 main terms, this one and this one. So let us expand in A, let us expand the terms. Or let us expand the brackets. Now this minus here really means minus 1. So this minus here is minus 1. So I'm putting a 1 in here. so that we understand it's minus 1 that has to be multiplied, right, by everything in the brackets. And then here, it's minus 2 that has to be multiplied by everything in the brackets. So let's do that. Let's say minus 1 by x will give us minus x. Minus 1 by plus 2c is going to give us minus 2c. Minus 1 by q is going to give us minus q. So let's continue with minus 2 by x is going to give us minus 2x. Then minus 2 by plus 4c is going to give us minus 8c. And then minus 2 by minus 3q is going to give us plus 6q. So if we group all the x's together, we'll end up with what we are looking for. So we're going to group the minus x with the minus 2x, right, which is this one and this one. We're going to group the c terms together, minus 2c minus 8c, that's these two. And then we're going to group the q terms together, minus q plus 6q. So let's deal with that. Minus q plus 6q. Okay, so let's see what happens now. The minus x and the minus 2x together will give us minus 3x. The minus 2c and the minus 8c will give us minus 10c. And the minus q and the plus 6q will give us plus 5q. And of course, this will be the answer that we were looking for part A. Alright, so that will give us our full marks. Let us now look at part B. So this is the answer for part A. Let us now take the answer for part B here. So let us deal with these items here firstly. So we're going to say the minus 2 by the 2, that's this one here, minus 2 by 2, that's going to give us minus 4. Right, that's this minus 2 by this 2 here. Then this x squared by this x cube, right, is going to give us, right, x to the power of 2 plus 3, right, because we have to add the 2 here and the 3 here to give us what the result is. Then we're going to deal with the p's. So p cubed and p to the power of 5, that would be p to the power of 3 plus 5. So in that way, we would have dealt with what is in the brackets, or I have enclosed in this enclosure here. Okay, then we'll deal with this part here. So we're going to just put that in, plus a quarter x cubed p cubed, and that's going to be all over xp. So this is going to come down to be minus 4, and then when we add up the 2 and the 3 here, we're going to get 5, and then when we add the 3 and the 5 here, we're going to get 8. So that will be p to the power of 8, which we will put here. Oh, let me just fix this here. That was minus 4 x to the power of 5, sorry, which came from here. All right, then the 3 and the 5 here give us 8, as we had said. So this will be p to the power of 8, which we will write right here, plus a quarter x cubed p cubed all over xp. So we are taking it step by step, so we'll get it all the way done. Then we're going to divide by the xp from here. We're going to divide by this xp here. Right, we're going to divide by this xp, the top, throughout these two. Now, the thing about it is, when you divide or you cancel here with x, both here and here, because these terms here are separated, by a plus sign, by this plus sign, the x has to divide into each one of them, here and here. Similarly, the p would have to divide, after we cancel it here, it'll have to divide here and here. So let's do that. Let's say x into x1, x into x to the power 5 here will give you x to the power of 4. Then when this p cancels here with itself, p will go into p to the power 8, p to the power 7. Because of course when we divide, if this is x, is really x to the power of 1 understood here. And when you divide x5 by x1, we have to subtract the indices. So it'll be the 5 from here, subtract the 1 that is understood here, which will give us x to the power of 4. And similarly, this p to the power of 8, when you divide by p, seeing that this was p to the power of 1, then the 8 minus the 1 that is understood here, let me just put them in so you would see them, right? This 8 minus this 1 is going to give us 7. So this will be p to the power of 7. And then we are going to do the same thing here because it's separated by a plus sign. So now this also has to go into these two terms here. So the x has to go into the x cube, and that will give us x squared. And the p has to go into the p cube, which will give us p squared. How is that so? Because 3 take away 1 will give us 2. Remember, we are dividing the same algebraic term, the x term, but the indices are different, so we have to subtract if we are dividing. So 3 take away 1 will give us 2, and this 3 take away the 1 here would also give us 2. So this will be x squared p squared. So coming down to write it finally, this is going to be minus 4 x4 p7 minus 4 x4 p7 plus, which is this plus here, and we have to write down a quarter x squared p squared. So a quarter x squared p squared. So that would represent our final answer for this particular question. That's our answer. Number 4, we have to factorize the following. The first one, which is a, is 9x cubed y minus 6x squared y squared plus 3xy to the power 5. And when we look at it, we see that we can use the HCF method of factorization, where we will take out the highest common factor. So here we are going to take out the highest common factor, which when we look among the numbers would be 3. And when we look at the terms, we would see that x is common, and the lowest power of x is x to the power of 1. So we will take out those two first. Let's write out that. So that'll be 3x, right? Because 3 here would be the highest common factor among the numbers, and x would be the highest common factor among the x terms. But remember, when we look at what is common, we notice you have x cubed, x squared, and x. So x is common in each term. We always take out the lowest power in terms of the letter. So this will be x to the power of 1 that we take out. Then when we look at the other letter, which is y, we notice that y is common in each term here. And the lowest power there is y to the power of 1. So we're going to take off that y to the power of 1, which is called simply y. Right, so that will actually be our HCF that we will take out from all of these. That will be our HCF. And we will have to fill in inside the brackets now. So let's do that fill in here. Alright, so if we divide 9x cubed y by 3xy, or we take it out as a factor, we're going to get 3x squared for the first term, right? Because x cubed divided by x right? X cubed divided by x will give us x squared, and y divided by y will give us 1. That is understood right here. Then we'll be dividing this term here, minus 6x squared y squared by 3xy. We are dividing a negative term by a positive term, and therefore the answer has to be negative right here. So we're going to put a negative answer right here. Then we say 6 divided by 3 will give us 2. So we're going to have to write a 2 here. X squared divided by x will give us x right here. Because we subtract the indices, the 2 subtract the 1 that is understood here will give us 1. So this is x to the power of 1. That's how we get 1 here. And y squared divided by y, right? The 2 here minus the 1 index understood above the y will give us 1. So therefore the answer here will be y to the power of 1. So we're going to write it in y to the power of 1. Then we divide in this by this. Both items are positive. Both terms are positive. So the answer is going to be positive. So we're going to write positive here. And then we divide 3 divided by 3 is going to have 1 there. So we write our 1. Right? X divided by x is 1. So that 1 is multiplied here by 1 to give us back 1. And y5 divided by y is y to the power of 4. So that will be 1 y to the power of 4, or just simply y to the power of 4. Now how we got the 4 there? The 5, take away the 1 that is understood here, will give us the 4 that is understood there. So we say this would be our answer. Now the 1 here is not necessary, right? So we could back that out. Let's take that out. Right? So our final answer is going to be 3xy, open brackets, 3x squared minus 2xy plus y to the power of 4, close brackets. Let me bring this bracket a little closer so it look a little neater. And that will be our final answer for A. Let's look at B now. Let's look at B now. In B, we have 4 terms. 1, 2, 3, 4. And once you have 4 terms, it's a hint that we are most likely going to be having to employ the method of factorization by grouping. So we're going to group these two, and then proceed. Alright, so if we group these two, we'll take out 2p as the highest common factor. 2p comes out, and when 2p comes out of this one, you'll be left with r. And when 2p comes out from this one, you'll be left with minus 2s. Of course, you can always multiply back in and see if you get the same answer. So 2p times r will give us 2pr. 2p times minus 2s will give us minus 4ps. So we know that this is quite correct. So let us proceed with this one here now. Right? And again, we can take out the factor plus q, or we can take out minus q, but we are choosing to take out plus q because when we take out plus q, what is going to be left in the bracket is going to be exactly like what is in this bracket here. Because if I take out q from qr, I'll get r here, so I'll write it in. And if I take out q from minus 2qs, I'm going to get minus 2s right here. Minus 2s. And of course this and this must be the same for factorization by grouping to work, to be able to be done. So all we are going to do now is to recognize that r minus 2s is common here, and therefore it is a common factor that we can take out. And if we take that out as a factor, from this pair here, we are going to be left with 2p. So we're going to write that 2p here. And from this factor here, from this group here, sorry, if we take out r minus 2s from it, we're going to be left with the plus q. So we're going to write down the plus q. Okay, so one way of looking at it very quickly is that the r minus 2s is what is going to come out here. And the 2p and the plus q is going to make up the other factor. So this would be the answer for this one. So let's write in the answer here. And that is our final answer for B. Let's look at C now. In C, we have 121 x squared minus 64. So I notice, and you should notice, that there's a minus sign here. And there's something squared. So it's cluing me into using the difference of two squares. But we have to express this and this as something squared in order to use the difference of two squares to factorize this. So let's express 121 as something squared. And that will be 11 squared. Let's express x as something squared. That will be x squared, of course. Let's express 64 as something squared. That'll be 8 squared. So this is what it's going to look like. Right? And once you have that, 11 squared x squared is the same thing as 11x all squared. And 8 squared, of course, is 8 squared. And this actually is the difference of two squares. This is the difference of two squares right here. So if we have two items here that are already showing us the difference of two items squared, 11x squared and 8 squared, then we can use the difference of two squares, which says that the difference of the squares of two terms, 11x and 8 being those two terms, is equal to the product of the sum and the difference of the items that was squared. So we have 11x and we have 8, and then we have 11x and we have 8. So ideally, to write it in its most perfect form, you'd have 11x plus 8 and you have 11x minus 8 in brackets as the final answer for this question. And that would be the factorization of the initial item C, 121x squared minus 64, when factorized will be 11x plus 8 times 11x minus 8. That would be the answer. In number 5, we have to solve 2x squared minus 5x minus 3 equal to 0. And we have to use both the method of factors and the quadratic formula. So we are going to use the method of factors firstly, and then the quadratic formula. So here we are going to find AC first, and AC is 2 times minus 3, and that is what we're going to write down here firstly, right? So we're going to write 2 by minus 3. That is going to give us minus 6. And then we are going to test to see if those two factors that we got, which are the 2, which is the 2 and the minus 3, if when we add them together, 2 and minus 3 added together, if it gives us this number here. 2 and minus 3 give us minus 1. And of course, minus 1 is not equal to minus 5. So therefore, those two cannot be the required factors that we are looking for. We have to find the factors of minus 6, which when added together give us minus 5. So if we go 1 by minus 6 will give us minus 6. So we are testing these two factors here. And they must, when multiplied, they must always give us back the initial value we got for AC. Right? 1 and minus 6 is quite fine as two possible factors. Now we must test them to see if when we add them together, we get minus 5 here or not. So let's add 1 and minus 6 together. We will get minus 5. So what that is saying is that these two numbers, 1 and minus 6, are the factors that we are interested in. These are the factors. So we're going to take these two factors, 1 and minus 6, and we're going to use the two of them here in this position. So we're going to use from here 1x and minus 6x to replace the minus 5x, because the mathematicians have told us that once we do that, we'll be able to solve the resulting equation using the method of factors, using factorization by grouping. So let's do that. Let's take this one and this minus 6 and replace use it to replace the minus 5x in the following manner. So we're going to have 2x squared minus 1x minus, sorry, not minus 1x, but plus 1x minus 6x, right? The plus 1 coming from here and the minus 6 coming from here. So let's continue. Minus 3 equal to 0. Now we continue using factorization by grouping, right? Utilizing these two groups. So from the first group, we're going to take out x, and we're going to get 2x plus 1. Then we're going to take out from the second group the number that will give us 2x plus 1 here, right? And the number that we need to take out, or the factor we need to take out from here, has to be negative 3. Because when we take out negative 3, we're going to get this in brackets being equal to that in brackets. So what then happens is that if we notice that these two are the same, it means then that 2x plus 1 can come out as a factor, and we'd have x minus 3, which is coming from here and here, as the other factor, and that must be equal to 0. Then either 2x plus 1 must be equal to 0, or x minus 3 must be equal to 0. In the first case, it would mean that 2x must be equal to minus 1, or in the second case, x minus 3 must be equal to 0. We're not dealing with that just yet. But in this case here, it means that x must be equal to minus 1 over 2, dividing on both sides by 2. Or the other possibility is that x must be equal to 3 from this factor here. So the answers would be x equal to negative a half or x equal to 3, right, would be the answers for this particular question using the method of factors. The next thing we have to do is utilize the method of the quadratic formula. So we are going to look at that in part B of this question in a moment. In this question, which is actually part B of number 5, or the second part, where we are required to use the quadratic formula to solve this particular equation, we have to recall the quadratic formula, which says that if we have a quadratic equation equal to 0, then the quadratic formula that will give us the solution would be given by x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. A lot of times students do not put in the all over 2a. They take the 2a and they put it underneath the 4ac or under the b squared minus 4ac. They don't put it all over, and therefore a lot of errors come in. The other thing that a lot of students don't do is to utilize the bracket system when substituting for each one of the unknown of the letters A, B, and C. I will show you the bracket system now. So first of all, let us re-establish what A is, B is, and C is. A from here will be 2 here. So we're going to put 2 right here, so we put it in. B is going to be this number here, which in this case is minus 5, so we're going to put minus 5 right here. And C is going to be this number here, which is minus 3. Because remember, it comes from ax squared plus bx plus c equal to 0. This being the general formula for, or the general form of the quadratic equation. So given that that is the case, we will substitute. But to substitute into this equation, we're going to use the bracket system, which is anytime we see the letter, let's say for example b, we will put a bracket, plus or minus the square root of, instead of b, we're going to put brackets squared minus 4 times, instead of A, we'll put bracket. Instead of C, we'll put bracket. And then we'll put that all over 2, and then we put a bracket. And just for emphasis, we will change our marker to something a little different in color. Let's use a red marker. We're going to use it to represent A, B, and C. Right? Let's just change the size a little bit so it can fit better. So for B, we know B here is minus 5. We're going to put B as minus 5 here. Right? B is also shown as B squared, so that'll be minus 5 here also. Right? So that's all the B's that has to go in there. Then we're going to substitute, right, for A now. But A is 2. So wherever we see A, like right here, we're going to put 2. Right? And down here, we're going to put 2 as well. And then the only one we have to substitute for is C. And C is minus 3. So we're going to put minus 3 right here. So that's very important. You need to be able to make the correct substitutions and be careful as you go along. So X therefore is going to be equal to, here it's minus 5, which means it's going to become plus 5. Then this is going to be plus or minus the square root of minus 5 squared is going to be 25. Minus 4 by 2 is minus 8. Minus 8 by minus 3 is plus 24. And that's going to be all over 2 times 2 at the bottom is going to give us 4 at the bottom. Of course, it's all over, so it's very important to have that all over sign. Then X therefore is going to be 5 plus or minus the square root of 25 plus 24 is the square root of 49, and that's all over 4 once again. So let's shift up a bit, right, and let's continue. So X therefore is going to be equal to 5 plus or minus the square root of 49 here is going to be 7 over 4. So that means that X, right, is going to be equal to 5 plus 7 over 4. Or the other possibility is X is going to be equal to 5 minus 7 over 4. So you have two possibilities, right? So therefore this would imply then that X can be 12 over 4, or X can be 5 take away 7 is negative 2 over 4. So what does that mean? It means then that X can be, let's fix this, it implies that X can be 12 divided by 4 is 3, or X can be, what is minus 2 divided by 4? It's going to be a negative 1 over 2, which is negative a half. Now, if we recall, X equal to 3 is an answer, or X equal to minus half is an answer, and these were the exact same answers, if we scroll back up, that we got when we used the other method, which is the method of factors. Here was X equal to minus a half or X equal to 3 was the final answers when we use the method of factors as shown here. And in this method, when we use the quadratic formula, being very, very careful how we place the numbers into the brackets, how we selected A, B, and C, and utilizing the correct formula and not changing the formula in any way, progressively all the way through, we ended up with the same correct answers. We have to find a binary operation, A star B. It's really an asterisk, but we'll call it a star to make it easy to speak about. So we have to find A star B, and that is given by the square root of A squared minus B squared. But we have to do it for minus 4 star minus 3. So here we write minus 4 star minus 3 directly below the original function. And we are going to let the minus 4 go to represent B, or to substitute for B, and similarly the minus 3, the minus 4 to substitute for A, sorry, and the minus 3 to substitute for B. So let's go back to our blue and we will write what is supposed to happen here. Where we see A, we will put a bracket and square that, minus, where we see b, we'll also put a bracket and square that. And the reason is to help us prevent errors due to the signs. So where a is, we're going to put minus 4. So right here, minus 4 is going to come in down here. And where b is, we're going to put or substitute the minus 3. The brackets really help us to avoid errors due to signs. So once we have gotten that in, it's just a matter of working out everything from there. So the minus 4 squared is going to give us 16. The minus 3 squared is going to give us 9. Remember, when we are looking at this particular situation here, we use BIDMAS. Now BIDMAS says we do brackets first, then the index, then division, multiplication, addition, and subtraction. So right here, we are going to do the index first. And that's why we say minus 3 squared is going to give us 9. And then we apply this minus sign to it. So that's why we now put in the minus. So we are going to end up with the square root of 16 minus 9, which is square root of 7. And when you get that, your calculator is going to give you the square root of 7 as 2.6. If you round it off to 1 decimal place. So it's 2.6 correct to 1 decimal place. Right? But you have to remember that it's plus or minus. Right? All square roots give us plus or minus, and we must always consider them. We must always indicate it. If it's a pure maths problem like this, you must write in the plus or minus, and your calculator is not going to give you the minus option. You have to know that from classes like this or from your other teaching and learning. Alright, so this is going to be our answer for this particular question.